Welcome back, folks. We are looking at this week's problem of the week for grade 5-6 once again. And this problem is coming from the Center of Education and Mathematics Computing. We did receive in our email, I believe this is the second to last one that we're going to get from them, that they're going to be stopping sending these problems here in a couple more weeks, but we do have a couple more to still work through. So we'll take a look at what we have here. The problem reads, these dice are D12s. Dice A, B, C, and D shown below are also known as D12s. A D12 is a 12-sided die with a distinct number from the set, 1, 2, 3, up to 12 on each side. And we see there are 4 choices there, A, B, C, and D. One of the 4 dice above can be made from the net shown below. Which of A, B, C, or D correspond to the given net? Now, if you're anything like me, you find these types of math problems to be very challenging. I am not great when it comes to spatial awareness and how these things work. And so when I see a problem like this, especially if I saw it on an EKO test, I'm going to turn to my manipulatives. And that's one of the great things about what the CEMC does, is it always gives us these models that we can work off of and develop. One question that does get raised, though, is why is it important to know how nets work? And the biggest reason, from what I've seen in my work experience, is anytime we will be using boxes to transport something, we will always have a need for nets and understanding how nets go together, because that's exactly what happens here. Anyone that has engineered a box to be able to store something or to transport something, they always have to start from a net and know how to fold it properly in order to create that situation, be able to create the box. So if I take a look, I created my manipulative by actually taking my sheet and I cut it right out. And so if you can see, that's what I ended up doing. So looking at my net right off the bat, when I was looking at it, I immediately identified that my 12 and my 5 I was going to use as my faces. And for my initial orientation, and then my 2 and my 6 is actually my line of symmetry when I was first looking at this. So I started from there and then I cut all my pieces out, and now I'm going to put it together. And so when I put it together, I can see in this particular case, what's kind of lining up is my 1, 2, 3 will come together to kind of form that side, if you folks can see here. I know it's a little bit small, but there's my 1, 2. My 1 is under my finger. I have my 2 and 3 in there. And then I continue to move it through, and I can see that my kind of looks like my 3 and my 4, my 10 and my 11 are going to kind of line up. Looks like my 6 and my 7. If I can get my angle right here, my 6 and my 7 and my 8 and my 9 are all kind of matching up here. And so that's how I'm really going to work this, is when I look at my 4 figures, I'm going to simply work off of my net. Ultimately, I think I can probably tape it together and figure out my problem from there. So if you're one that's very good at spatial awareness, you will likely be able to just look at this net and be able to determine. But if it's one that you're finding to be a little bit challenging, this is a suggestion that I would make. So good luck, folks. Hopefully you can solve it and go from there. We'll see you next week.